Kuzu Zangpo. Welcome to Bhutan e-learning project. I am Ishi Chotin. I will take you all through math lesson for Key Stage 4, that is for classes 9 and 10. The topic for today's lesson is on probability. As you see, this topic isn't new to you all. You already have some basic ideas on this topic. So let's review what you already know on the topic. So my first question is, what are probability devices? The probability devices are coin, dice, cards and spinners. So these are some of the probability devices that we use. My next question is, what are some of the methods that we use to calculate probability? As we recollect, some of the methods to calculate probabilities are listing, using outcome chart and using tree diagram. So these are few methods we use to calculate probability depending on the events that is being described. Now my next question is, how do we calculate theoretical probability? So probability of any event is equals to number of favorable outcome by number of sample space. Now sample space refers to all the possible outcomes for the given event. So these are some of the basic information that you have already learned in your earlier grades. So the focus today would be on distinguishing independent and dependent events. Now when are events called independent? The events are said to be independent when the outcome of one event doesn't affect or depend on the outcome of another event. And the events are said to be dependent when the outcome of one event affects the outcome of another event. So let's consider few examples to distinguish whether the given events are independent or dependent. So we have the first example. In example 1, event A is described as rolling a die and getting even number. Event B is described as tossing a coin and getting tashitage. The events here, events A and B, are independent as the probability device used are different. The outcome of event A doesn't affect the outcome of event B, as the device used in event A is a die and the device used in event B is a coin. So the outcome in rolling a die doesn't affect the outcome of tossing a coin. That's why the events described are independent. Now let's consider example 2. In example 2, event A is described as drawing a king from a deck of cards in first draw and the card is not replaced, and event B is drawing a king in a second draw. So if you look at the two events, the events are dependent because the outcome of event A affects the outcome of event B, as the card that is drawn in event A is not replaced when event B happens. So in a deck of cards, how many cards are there? There are 52 cards. So the number of sample space for event A is 52. So the favorable outcome described in event A is drawing a king. So in a deck of cards, how many king cards are there? There are 4. So outcome of event A is 4 by 52. Since the card is not replaced when the event B happens, the outcome of event B is going to be 4 by 51. So you see here the number of sample space is affected. So that's why the events A and B are dependent events. So this is how we distinguish independent events and dependent events through reasoning. Now let's consider example 3. So in example 3, event A is described as rolling a die and getting 1 in the first roll. Event B is described as rolling an even number in the second roll. So if you look at these two events, it's quite difficult. It's quite difficult to determine through reasoning whether the events are independent or dependent. So in such cases, we determine it through calculation. So let's do the calculation using certain steps. So in the first step, we calculate the probabilities of event A and B happening as a separate event. So what is the probability of event A happening? So we get the probability of event A happening as number of favorable outcome by number of sample space. So the event A is rolling a die and getting 1 in the first roll. So when you roll a die, how many possible outcomes are there? There are 6 possible outcomes, that is sample space. And out of the 6 possible outcomes, how many faces are marked with 1? So there is only one face marked with 1. So the number of favorable outcome is 1. So the probability of event A happening is 1 by 6. Now let's calculate probability of event B happening. So the probability of event B happening is equals to, so number of sample space. So in event B, we are looking for getting an even number. So how many are even number out of the 6 sample space? 3 are the even number. 2, 4 and 6. 3. So number of favorable outcome is 3. So which when we simplify, we get it as 1 by 2. So the probability of A happening and B happening is equals to 1 by 6 times 1 by 2, which is 1 by 12. So this is the first step. Now in the second step, we determine the probability of events A and B as a combined event. So that is probability of A and B. We are going to calculate probability of A and B. That is, you have to take it as a combined event. That is getting 1 in the first roll and getting 2 even number in the second roll. So for that, we need to use outcome chart. Let's use outcome chart. So I will keep the possible outcomes for first roll vertically. So when you roll a die, how many possible outcomes are there? There are 6 possible outcomes. 1, 2, 3, 4, 5, 6. Similarly, when you roll the same die for the second time, again you have 6 possible outcomes as 1, 2, 3, 4, 5, 6. So I have kept horizontally as the second row and vertically as the first row. So these are the least of all possible outcomes. The least of all possible outcomes. There is a possibility that you might get 1 on both the rows, or 1 on first row and 2 on second row, 1 on first row and 3 on second row. So this is how you fill up the outcome chart. So here I have the completed outcome chart. So what is the favorable outcome that we are looking for? We are looking for getting 1 in the first row and even number in the second row. So how many favorable outcomes can you see on the chart? 1 in the first row and even in the second row. Here's another one, 1 in the first row and even in the second row. 1 in the first row and even in the second row. So these are the favorable outcome. So that's why the probability of A and B happening as a combined event is 3 by the total number of possible outcome is 36, which when we simplify is equals to 1 by 12. So this is the second step. Now in the third step, we compare the probability results in step 1 and step 2. Probability results in step 1 and step 2. Probability of A and B happening as a combined event. So the result of probability of A and B happening in step 1 was 1 by 12. And the probability of event A and B happening as a combined event was also 1 by 12. So you see that the probabilities are equal. Therefore, the events A and B are independent. So when the probabilities are equal, you can conclude that the events are independent. But if the probabilities are not equal, then you can conclude it as the given events as dependent events. Now let's consider example 4. In example 4, event A is described as rolling a die and getting 1 in the first row. Event B as rolling a sum of 5 in 2 rows. So can you tell me the first step? So the first step is again calculating the probability of event A and B as a separate event. So probability of A would be 1 by 6. And probability of B would be rolling a sum of 5 in 2 rows. So you need to again use outcome chart. But this time we are looking for sum of 5. So I'll keep along vertical as the first row. So there are 6 possible outcomes when you roll a die. So horizontally as again second row. Again you are going to have 6 possible outcomes when you roll a die. So to determine the probability of event B, you need to use an outcome chart because you are rolling and looking for a sum of 5 in 2 rows. So we'll keep vertically as the first row, possible outcomes for first row, horizontally as the possible number of possible outcomes for second row. So since we are looking for the sum of 5, So the outcomes should be added. So there is a possibility that you might roll 1 on first roll as well as 1 on second roll. So the sum would be 2. There is a possibility that you might roll 1 in the first roll and 2 in the second roll. So in that case, the sum would be 3. So this is how we go on. So if you roll first, 1 on first die and 3 on the second roll, it would be 4. So this is how you go on filling up the chart. The next sum would be 5, 6, 7. And if you happen to roll 2 on the first roll and 1 on the second roll, the sum would be 3. And it continues 4, 5, 6, 7, 8. So there is a possibility that you might roll 3 on the first roll and 1 on the second roll. In that case, the sum would be 4. And next would be 5, 6, 7, 8, 9. So this is how you fill up the outcome chart. If you get 4 on first roll, 1 on second roll, the sum would be 5, 6, 7, 8, 9, 10. Next would be 6, 7, 8, 9, 10, 11, and it goes on. This is how you fill up the outcome chart. So what is the probability of getting event B? You have to look for sum 5. So how many favorable outcomes are there on the outcome chart? 1, 2, 3, 4. So there are 4 favorable outcomes. So it is 4 by 36, which when we simplify is equals to 1 by 9. So probability of A and B happening would be 1 by 6 times 1 by 9, which is 1 by 54. Now what is the next step? The next step is to calculate the probability of event A and B as a combined event. That is, you should look for a favorable outcome where you get 1 in the first roll and sum of 5 in the second roll. For that too, we need to prepare outcome chart like before. So we keep vertical as first roll. So the possible outcomes are 1, 2, 3, 4, 5, 6, and we keep horizontally as the second roll. So the possible outcomes are again 1, 2, 3, 4, 5, 6. So this time we are looking for getting 1 in the first roll and getting sum of 5 in the second roll. So the possible outcomes are 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. And the second row would be 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, and you can fill up in the same manner the rest of the boxes. So for now we have to look for getting 1 in the first roll and sum of 5. So there is only one favorable outcome where you roll 1 in the first roll and where its sum is 5. So only if you roll 1 in the first roll and 4 in the second roll, the sum would be 5. So the favorable outcome is 1. So probability of event A and B as a combined event is 1 by 36. So what is the last step? We compare the probabilities of step 1 and step 2. So in step 1 we got the probability as 1 by 54, which is actually not equal to the probability that we got in step 2, that is 1 by 36. So you see here that the the probabilities are not equal. That's why the events A and B described in example 4 are dependent. So if you reflect on today's lesson, you will see that in the first two examples, we have used reasoning to distinguish independent and dependent events. And in example 3 and 4, we have used calculation to distinguish independent and dependent events. So when it is not possible to use reasoning, you can always use calculation to distinguish independent and dependent events. I hope that now you are clear with distinguishing independent and dependent events using reasoning and calculation. Thank you for attending today's lesson.